All right. Hello, everyone, and welcome to our second edition of Spatial Spotlights here at Cardo. My name is Matt Forrest, and I'm excited to be with you today to talk a little bit about site selection in telecommunications for new towers. Welcome, everyone. I'm still figuring out the technology a little bit, but I think we all got it to work. So everything's moving along here. Quick housekeeping notes. If you have any questions, you can go ahead and add those to the comments. Looks like the audio is coming through great, which is awesome. Anytime you have any questions, feel free to drop those in. We'll get to them, or I can review them as well, and we'll go from there. So before we get started, I'm just going to share a few quick slides to kind of talk about the use case and what we're going to be handling today. We're talking about telecommunications site selection and actually finding a suitable location for a new cell tower. And there's a few different considerations we want to take into account when we actually do this. So the first is that around data, right? There's many different data layers that we want to use to actually understand this problem. That could be things from elevation, building heights, tree canopy, all of the physical attributes in the location we're looking at, as well as the attributes about maybe our customers or people or existing cell service, maybe where we have retail locations. So as you can start to see, there's a lot of different data layers that could potentially be a part of this problem. The other component is that the data types are different, right? Not all data is at the same weight. We might want to overemphasize some attributes like tree canopy and elevation simply because of the fact that we, are those are physical things that we have to kind of adjust for and handle. So that's another component that we want to take a look at. The other component that we want to start to understand is using location, right? Variables are different between and even within our markets, right? We're going to take a look at Denver, which is at high altitude and mountainous and things like that, versus other areas that are going to be completely flat. And how do we account for that in new and existing markets? This also, we have to account for data updates. Some of this data is going to be completely static. Of course, elevation doesn't change too often, and some data is going to be updated, even daily or even more frequently than that. And then the final bit is around spatial scale. We have elevation and DEM profiles that might be coming at the level of, a handful of meters versus census data that's covering, large areas, and then, even coverage data, which could be very granular or very detailed. So we want to adjust for the spatial scales and support systems as well. So let's jump into the demo, and then we'll actually look at a map here that we created from the output. So I'm going to go ahead and share my screen. Let's make sure that's working here. And the first thing we're going to take a look at is the workflow to accomplish this. Now, this might look like there's a lot of different steps involved, which certainly there are. There's a lot happening here, but we'll go through each step and kind of talk and break through what's happening in this workflow. So let's zoom in here. I'm going to take a look at this, and we'll start with first our buildings data set. So this is a data set of buildings in the Denver area. This is all open data, so if you're interested, I can share this data with you, and you can play around with this as well. But the first is our buildings data set here. So we actually have a total list of buildings in the area. And we first filter those based on two attributes, whether they're residential or if they're 50 feet and above, right? 50 feet and above is basically saying that most of our towers are going to be taller than that. So we want to account for very tall buildings that could interfere with our signal. And then for residential areas, we want to find buildings in that area that will be people's home locations, right? So that's a good proxy to understand that. The other component is we have our elevation records. So this is data from, I believe it's the Denver Metro. I can share the data sets here too, but it's a DEM that I've converted to vector. And you can see here, it's just at around almost 500 million different records here. The next data we're looking at is telco coverage in the area. We don't have the real data for this, but we do have a good proxy. There's the Ookla open data set, which I highly recommend checking out, which has global data coverage already aggregated at the quad bin level that you can use. I believe it's hosted on AWS, and you can download that for free. We also look at different data from the competitors, where are their physical competitor locations, and where are their physical store locations. So we can use those. The final step is cell towers. So I used a data set from Open Cell ID, which has a really great data set of tower locations globally. Once again, great open data that you can use here. And then the final bit is using our mobile network codes that we want to actually understand which network it is. So we're pretending to be a specific network provider in the United States and using that as the proxy here. The final step is actually population data. So this is data that we have in our Open Data Observatory. Now, the goal and where we want to get to with this is the map that you're going to see here, which is a simple readable index that tells us where there are more suitable or less suitable locations to go based off of all this data. And as you can see, we're using the H3 spatial index system to aggregate that data and create one very readable index here. So that's really our goal, is to get all of this data into one single spatial support system that's very easy to use. Basically, what you're seeing here is the darker areas are more suitable for a cell tower, the lighter areas are less suitable. And we'll see what that turns out with here. So to begin, basically, there's a few different steps here. This first, grouping of data is within the red is basically bringing our data to the H3 level and then normalizing that data on a reference scale from 0 to 1. Now, of course, when we normalize our data, you might have, population data that has everything from 0 people to maybe 10,000 people, and you might have income which goes from 0 to 60,000. So these data scales are off, which is why we need to perform this normalization step, which is really quite simple here. You can actually just pick the column you want to normalize and some different options here that you can use, and that will scale that from 0 to 1. The other pieces that we have here are basically pulling in and creating this down to the H3 level. So we might be pulling these in and pulling it into a centroid, then creating the H3 from the geography point. Sometimes we're doing some polyfilling here. In this case, the Telco Denver dataset is at the quad bin level. So we just need to create the quad bin boundary and then turn that into an H3. So just in effect, these are different steps to accomplish the same thing, which is normalization of the data and then turning into that spatial index, which we'll use for the final step here. So in this case, we're creating a simple 1 mile buffer around the location and then using the H3 polyfill to fill that in. At any step, of course, if I want to take a look at this, I can see what this looks like at the map level. Here are all my locations for my current stores at an H3 level. You can see the data here and pull all of those steps in from that perspective. So each step is basically, you can check those at any time. Again, here, there's a variety of different things that we can do to pull these into the H3 level. This is the cell towers. And then finally, we already have these H3 levels here, that level 8 from our population data set. So that's really the first step. I know it looks like there's a lot happening here in terms of lots of different pieces, but that's the end goal, is to get all of that data into that H3 format. So in this section of the orange components, that's what we've accomplished here. The next step is to drop the columns of data that we don't need, right? We don't need every single column that we want. What we really care about is a numeric field and the H3. So that's all that's happening here, is that we're selecting just the columns of data that we need from each different component. So we have, we're filtering down to each of these. We're doing some grouping as necessary. So we're grouping by the different values here, whether that be elevation. In this case, we're going to choose an average and a maximum, grouping by the H3 level, and then different steps here as we need to for each of these. So we're counting competitors and doing all these grouping components here. So that's really what's happening. In some cases, we're downscaling that or going to a lower level. In that case, we can use the nesting function, which just allows us to work with arrays and things like that. So just to recap, we pulled in our data, did a little bit of filtering here, and then ultimately did a variety of steps to group and turn our data into the spatial index and normalize that data. Here, we're just selecting the core columns that we need. Once again, that's our H3 index and our numeric data. And then finally, we're joining all these data components together. That's all that's really happening in this giant pink box, is that we're just joining all of those disparate sources together. Now, the final green step is really where we're creating the actual values out of this. So what we're doing is we're creating a composite score where, since we know every column is going to be contained from 0 to 1, we can sum that up and divide that by the total. So in this case, I created a simple score which just has effectively a few different variables in it. This is the non-residential buildings, elevation, the download speed, competitors in stores, and then the number of towers. In this one, I can include every single variable, which includes all the variables listed before, as well as elevation and building height the normalized building height in total. So there's a few different ways to look at this. And another component that you could include here is a weighting metric. So let's say we really care about elevation. We can weight that as one, and then basically multiply these by a fraction or a decimal degree to choose the weighting system that we want. If we want to multiply 1 by 0.5, 1 by 0.25, we can choose the weighting and make that as appropriate as we need to from there. So that's all the steps here. And all this really requires is the building and orchestration of that. You can go ahead and run that, and that will push that out. The great part here is any new data that comes into these earlier data sets will get automatically updated every time you hit run. So you hit run, that takes care of the process. And in the end, we're processing about 5 million individual data points here, which ends up with this map. So what we have here is our actual index. This is the full composite score index, which we can take a look at, and you can actually filter this by different variables that you want to. So right here we have the non-residential building index, which you can see these are the areas that have a high number of non-residential buildings. This is telling you where those downtown areas and things like that. If we want to look at areas with high total population, we can start to filter those in and see where a lot of people live. So you can filter each component individually as well as an aggregate. To do that, it's really simple in Builder. We'll go ahead and pull our full composite here. That's layer G. We'll create a histogram. We're going to pull our composite score here, which is our composite. We'll choose the average in each cell. Let's limit the number of buckets to maybe 8, and we'll go from there, which should be down here. So as you can see here, we can filter and move this around to get our full composite scores. Let's change our number formatting so it's a little bit easier to read. And then we can kind of pick what we want. So these are our best fit areas here that we'll start to take a look at. So in short, where we look at the best fit areas, you can kind of start to see where that comes together. We're looking at areas that have, high population. You can start to see the individual aggregate scores here. They're lending towards a population, non-residential scores. So they have, they're actually not in those areas with dense, commercial buildings, but actually areas where people are living. So these are obviously neighborhoods and things like that obviously have some coverage. And there's some other factors that we might want to look at in that as well, which could actually include our other layers. So what's great about this is that you can explore the index in detail, but I can also take a look at other factors. So this is the cell towers data set, right? This is the actual number of towers that we have. And in this case, we were modeling after T-Mobile to actually see what their towers look like. And you can see there's a very clear pattern. Lots of towers in the central business district and along the highways and roads here. And if I actually filter out and clear this index, you can see that the scores are lower here where we already have a high density of towers, right? You have a ton of towers here. But when we filter to those areas that we really want to focus on, we can actually see that some of those have a lower density of the individual towers here. So they're actually lacking these areas, which makes sense. If we're targeting areas to put new towers, we don't want to double up where we have. You can also take a look at where your competitor towers are here as well and understand that. And then in the final step, let's turn that layer off. Now you can also take a look at your retail locations. This tells me, yes, I do have a retail location nearby, and this is an area where I may want to actually add a new location. So most of these residential plus, lack of towers, plus we have a retail location to service those customers all starts to make sense here. You can see we have our buildings layer as well, where we have our non-residential large buildings that could interfere with signals and things like that. So we can actually see those on the map as well, and then get even more detail into things like elevation. Of course, Denver, the city itself, is pretty flat until we start to get into the mountains here over to the west. So that's kind of the view here. You can take all these different layers together, really play around with it, and then explore it in very granular form as you see fit too, to really get a good understanding of what's happening in that market. So that's really what we ended up with for this type of analysis. Now, I did want to talk about what we could do in the future here, and I'll just share a few quick slides to talk about what else we could do. Now, this is a use case we talked about at the Spatial Data Science Conference in London. And this is the same type of thing, which is looking at heat islands, which has a multiple sets of layers that are deep data that we want to understand, looking at temperature, NO2 concentration, so on and so forth. So what do we want to do is actually showing that data is one thing, but describing it is even more important. And of course, this is a great application of the large language models or generative AI to give it a very clear prompt to help describe what's actually happening there. And what we could do is actually do that here to talk and describe those locations. This location, in this case, we're talking about air quality, high house prices, and a low crime rate. What we could do is do the same to say this is within 1 mile of a store. This has a low density of current towers, high density of competitor towers, so on and so forth. And the final step is that we are actually working on bringing this functionality right into workflows. So what you can do is basically take that data that you're already building out as an index and turn that into something that's very descriptive within text, and actually share that so anyone can really read that and understand on a granular level, just like I'm describing to you here today, but with text generated from AI. So that's really the final kind of version of this that we'd like to get to, and we're working on bringing right now, is actually labeling your data in a very readable way for someone who might not always be interacting with a map interface like this, like some of the people watching here. So that's the spatial, kind of analysis that we performed and everything for today. Just want to quickly thank you for all for being here. If you do or you're interested in these data sets, want to use this analysis yourself, have any questions, feel free to reach out to me on LinkedIn. I think you can grab that on the LinkedIn Live here. Ask me any questions or throw some things in the comments. But first of all, thank you all for taking some time to watch this. I hope this was informative and helpful. And yeah, like I said, reach out. We hope to hear from you. So thank you, everyone, and enjoy the rest of your day.